Day 15 of 60 in the Go Backend Challenge. Today we fix the auth mistake that shows up in almost every security review I've seen. JWT middleware that looks correct and is quietly broken. Before we write a line of code, watch this HTTP trace hitting a protected route. First with no authorization header, then a tampered token, then an expired one, then a valid one. Your middleware has to handle all four. By the end, you'll issue tokens, validate them with algorithm pinning, inject typed claims into context, and revoke compromised tokens mid-flight with Redis. Let's go. Start with issuing. A JWT is 3 base 64 parts: header, claims, signature, and the signature is the whole game. We sign with RS-256, not HS-256. Why? RS-256 uses a private key to sign and a public key to verify, so your auth service holds the secret and every other service only needs the public half. Define a claims struct embedding JWT.registered claims. Add your own fields like user ID and role. Then issue token builds the claims with expires at, not before, issued at, and issuer set. Calls JWT new with claims with signing method RS-256 and signs with your private key. Tokens are now self-contained. No session table lookup required. Now the dangerous part, validation. The classic exploit is the ALG, none attack, and a cousin called algorithm confusion, where an attacker flips RS-256 to HS-256 and signs with your public key as if it were an HMAC secret. Golang JWT won't stop this for you. The defense lives in your key func. Inside parse with claims, the key func receives the parse token, and you must assert the method. If token method isn't a asterisk JWT, signing method RSA, return an error immediately. That one type check pins the algorithm. Without it, you're trusting the attacker's header. Pin first, then return your public key. Validation order matters too. The library checks signature and standard time claims, but you verify EXP, NBF, and ISS before you read a single custom claim. Pass JWT with valid methods to restrict accepted algorithms, JWT, with issuer to enforce ISS, and let the parser reject expired or not yet valid tokens. The rule: never read user ID or role from a token you haven't fully validated. A tampered token that fails signature check should never reach your business logic. Validate token returns asterisk claims only on the happy path, and an error on everything else. No half-trusted state. Wire it into middleware. JWT middleware wraps the next HTTP handler. It pulls the authorization header, strips the bearer prefix, and calls validate token. On failure, write 401 and return, do not call next. On success, store the asterisk claims in the request context with value under a private context key type, never a bare string, so nobody collides with your key. Then call next.serve HTTP with the enriched request. Downstream handlers get a claims from context helper that does the type assertion once and returns a clean asterisk claims plus an OK bool, so you're not scattering unsafe assertions across every handler. Here's the truth about stateless tokens: you can't revoke them. A valid signature stays valid until EXP. So if a token leaks, you need state after all, just a tiny bit. Add a revocation layer keyed on the T claim, a unique token ID. Revoke token takes the T into TTL and runs Redis ctex with the TTL equal to the token's remaining lifetime. So the revocation entry self-expires exactly when the token would anyway. No unbounded growth. Is revoked is a single Redis exists check. The middleware gains one line. After validation, if is revoked, claims.id, return 401. One performance gotcha teams miss. Parsing the RSA public key on every request is expensive, roughly 120 microseconds per call. Do it once. Wrap the key load in a sync. Once, so the asterisk RSA.public key is parsed at startup and reused across every request, dropping that cost to about 2 microseconds. Same idea for your Redis client. One pooled connection, not a dial per request. Cache the expensive, stable things. Recompute only what actually changes per request. Run the test table, expired token. Fails, tampered signature fails, alg none fails, revoke T fails, valid token passes with claims in context. All green. And know when to stop reaching for JWTs. If you need instant revocation or you're storing lots of state, opaque tokens backed by a store are simpler and honest about being stateful. Day 15 done. The takeaway: JWT security isn't about the library. It's the validation order you enforce in your own wrapper. Pin the algorithm, validate before you read, and keep a revocation path. Subscribe for day 16.